So in this video, we'll be discussing equation or maximum likelihood estimator. Here, we are given the PDF and asked to find the maximum likelihood estimator of theta from this PDF. So all we need to do is to take the likelihood function. The likelihood function of f of x theta will be equal to the sum product of this function 1 all over theta squared x exponential x theta. So the sum total or the likelihood function of this will give us 1 all over theta squared n summation xi's and exponential xi's all over theta. So if we take the likelihood function of this PDF, this is what we'll get, because here we'll sum it n times, we'll sum xi's and the exponential value. So what do? The next thing to do is to take the log. But for we to take the log of this, we need to rearrange this very well. We rearrange this function so that it will be very easy for we to take the log. So rearranging it, we can write it as theta negative 2n raised to the power of negative 2n summation xi's exponential summation xi all over theta. Nothing has changed. Nothing has changed. So we can now take the log. Taking the log, we'll say log the log of this function, xi theta will be equal to, if we take the log, we'll have negative 2n log theta plus summation of log xi. If we take the log of an exponential function, we get that same function. So we'll have negative summation of xi's all over theta. So we have this as this. The next thing to do is to take the differential with respect to theta. So we differentiate with respect to theta after taking the log. So if we differentiate this function, log f of x xi theta all over the theta. If we differentiate this function, we get negative 2n all over theta plus, if we differentiate this function with respect to theta, we get 0. Please, for more on this, you need to subscribe to this channel. Then minus, if we differentiate this with respect to theta, we get something like this. That means 1 all over theta, which is the same thing as theta negative 1. So if we differentiate this, we'll have negative theta negative 1 minus 1, which is negative theta raised to the power of negative 2, which is the same thing as 1 all over theta squared. So if we put this here, we'll have all over negative summation xi's all over theta squared. So this is what we get. It means that this is equal to negative 2n all over theta plus summation of xi all over theta squared. So we equate this to 0. For maximum likelihood, we equate it to 0. Equating this function to 0, we have negative 2n all over theta is equal to negative summation xi's all over theta squared. So this will cancel this. We cross multiply. Cross multiply. Once we cross multiply, we get theta squared all over theta is equal to summation of xi all over 2n, which is the same thing as 1 all over 2 summation of xi all over n. So this will cancel this. We'll be left with theta estimate. Our theta estimate will now be 1 all over 2. Of course, we know this is same thing as 1 all over 2 mean. So we have 1 all over 2 this as our estimate. So this is how to compute the maximum likelihood estimator for theta given that function. For more on this, you need to subscribe to this channel.